Hello, welcome to Anatomy Physiology lesson 2.03, continuing on the different types of epithelial tissue. So we left off last time with simple squamous and simple cuboidal, and we're going to pick up today with simple columnar. So let me go ahead and share my screen. All right, this guy has got to go. There we go, that's better. All right, so we're going to talk about simple columnar today. And we've mentioned it a few times. This guy to the top here, myself at the top, maybe. Again, because it's simple, we're talking about one layer. When you're trying to determine how many layers you have, you want to look at the nuclei. So if I look at this, I have nuclei here, and they're pretty much in a single row. I don't have nuclei above and below, so that tells me these are one column. What's this? So this is my epithelial tissue. So what is this going to be called? Did you say the basement membrane? If you did, that would be correct. That means that this is the apical surface and this is the lumen. What we're looking at is they've cut a section. So we're looking at lining of the intestines, and they basically cut a section. If you follow my cursor, it's like they cut this section out here. And that's what we're seeing up here. So simple columnar epithelium, sometimes it has cilia, sometimes it does not. Excuse me. Can be ciliated or not. And in this case, this, believe it or not, is not cilia. Do you see how it looks fuzzy? That's called a brushed border. And we're going to talk about why this has a brushed border. So the function here is absorption and secretion. Function is absorption and secretion. Give me a second to catch that up. If you think about the lining of your intestine, and we mentioned this back on the front page, especially your small intestine, all the foods that you eat have to get broken down, and that happens pretty much in the stomach and at the beginning of the small intestine. And then the middle to the last portion of your small intestine, we have to absorb all of that into our blood. The lining of the small intestine has folds, and then each of those folds has folds, and the folds of the folds have folds. So it is really, really, really folded. And when we do the digestive system, we're going to talk about the reason for that is surface area. Absorption is directly dependent on surface area. And so the more surface area we have, the better absorption we have. We're also secreting substances. We're secreting mucus. You have a mucus lining on the insides of your intestines, and that helps lubricate and get the food moving through, helps keep, it's actually called chyme, and helps keep everything running. So, but look at these blood vessels. So you have large blood vessels, and then inside each of these smaller smaller folds, each large fold has a blood vessel. And then if you could zoom in, you'll see that each of the smallest folds that we have a tiny, tiny capillary that come up and carry away what's absorbed, and they drop off things that we want to get rid of. Not so much here as in the alveoli, but we definitely do an exchange. These folds are called microvilli. All right, this all came up as one block, so let me give you a second to catch your notes up. So our location, the lining of the stomach and the small intestine. The small intestine has microvilli, the stomach doesn't, and lining the oviducts. Okay, So we do have a simple columnar lining the stomach, but the stomach lining does not have microvilli. The small intestine has microvilli, and these are the folds because we have so much absorption and secretion going on in the small intestine. When we have microvilli, it looks like we have maybe cilia that just are like zoomed out, but that's not true. This is called a brushed border. If you've ever been in art and you take like an eraser and you soften the edge of something, you call it brushing the edge, making it soft. Microvilli have that brushed border look. Um, and that's what your brush border cells with lactase enzyme. Uh, don't worry about the lactase enzyme, but this shows you a microvilli forming the brush border. Again, this is your whole intestine, and then they took a little tiny circle of that and they blew that up. But so we've got our connective tissue down here. So what we're looking at here is this. And then on the outsides, we have the simple columnar, and then we have the microvilli on top. And again, those folds giving us the ability to absorb. We also have simple columnar lining the oviducts. This does have cilia. I don't have a picture of that. And almost always when you're asked about simple columnar on a test, it's almost always the lining of the small intestine and these microvilli. So it's a very characteristic, specific characteristic. All right, moving on to our next tissue. We have pseudostratified columnar epithelium. That is saying a mouthful. When you say that, you sound like you're really smart. All right, so we have a couple of labels up here. I don't think these are written on yours, so let's let you get these labels in here. This is my connective tissue down here, so this is going to be my basement membrane. The arrow's just a little bit off, probably should be pointing to this, for me, pink line. And what's this pointing to up here, guys? Did you say cilia? It's the same slide as we had on the first sheet. So you're going to want to write cilia in here. And then this arrow, the middle arrow, is pointing to a goblet cell. All right, I already clicked my first line item. I didn't mean to do that, but it popped up. So pseudostratified columnar epithelium. If you look, it looks like I've got columnar cells. Those look like a column, right? And if you look at my nuclei, it looks like I have layers, but I don't. So bullet point number 1, it appears layered. They appear layered, but are not. Appear layered, but are not. That's why the pseudo. Pseudo means fake or false. So these are fake layers. It psyched you out. What this means that if you could follow back this cell, it attaches to the basement membrane. If you follow this cell back, it continues to see the white there. It goes all the way and it attaches to the basement membrane. Each one of these cells attaches to the basement membrane. It's kind of crammed together, but they're not stratified. All right. And the most common location is your respiratory tract, specifically your trachea. So we're going to look at lots and lots of slides of pseudostratified columnar, and it's almost always the trachea. And again, I just ate, feeling a little bit, congested. My cilia are passing that, whatever it is, I've got some allergies, the cell debris. Usually, actually, when you have snot, it's a mixture of mucus, cell debris, drainage, and you need to get it up and out. So your cilia pass it up, and then you cough and it comes up. Sometimes, very, very often, these are ciliated. It's not 100% of the time, but often. So I'll give you a second to write. Also called ciliated mucous membrane. And the substance producing the mucus are, let's see if this is my next, goblet cells. So goblet cells produce the mucus, and we'll talk about goblet cells. When I'm trying to find, when I'm trying to identify if something is a goblet cell or not. So a goblet cell is what produces the mucus. I look at the top of the tissue. I look at the apical surface. My lumen's up here. And do you notice how there's a break in the cilia here? And it looks like there's stuff coming out. That's a pretty good tip off that this is a gland. And goblet, it's named goblet cell because this looks like a very thin champagne glass or champagne goblet. And the base of this goes back down to the basement membrane. It's hard to see the bottom of these. If you look here, you could see that, yeah, there's a little bit of disruption here. This is also a goblet cell. This is probably a better example. Those are the best two that I see on this slide. But again, just like we needed in your intestine, you need mucus. So mucus is doing three things. You could make a little side note somewhere. Mucus, 1, 2, and 3. Number 1, it lubricates. And it doesn't matter if it lubricates, so it lubricates a surface. So if you're swallowing food, your esophagus has mucus. It lets the food pass. If you have, it's not as much of a factor for your trachea. In your trachea, in your respiratory tract, the mucus is also sticky, and it's trapping particulates, it's trapping invaders, it traps bacteria. So mucus function number 2 is it is sticky and it traps foreign substances. Number 2, mucus traps foreign substances. So we said lubricates, we said traps, and it keeps, the third thing is, some of you hate this word, it keeps things moist. So you have mucus in your sinus membranes. You don't want these membranes to dry out. You need them to stay moist. So those are the 3 functions for mucus, and you do need to know those. So if I'm looking at something, how do I tell if it's pseudostratified columnar? Well, first of all, I always look at nuclei first when I'm trying to identify a tissue. So if I looked at this, I would say, okay, this looks like stratified, but I have 3 choices for cells that look like this that could be stratified. I could have stratified columnar. I think you could pretty much right away eliminate stratified cuboidal. These don't look cuboidal at all. So is it stratified columnar or is it pseudostratified columnar? Stratified columnar are going to have very neat rows of nuclei. You'll have 1 row of nuclei, 2 row of nuclei. These nuclei are kind of hodgepodge and helter-skelter. And so it's a little bit tough to tell, you can't see that there's just a straight line of nuclei. So that's your tip off that it's pseudostratified. In addition, I have cilia. In addition, I have goblet cells. So the thing about identifying tissues is you have to take all of your context clues and put them together. What you're going to be doing in this chapter is you'll be doing the videos on your own at home and taking the notes. And then in class, we're going to be looking at slides. We're going to be practicing. We're going to be running practicals. Practice practicals, and then your test will be a partial practical where you'll have slides and you'll have to identify tissues that you haven't seen before. All right, let's do one more tissue today. Let's do transitional, and this is kind of a good one to do. So here I have my, it's a relatively quick one. That's why I say it's good to do. At first, you might think this looks a little bit like pseudostratified columnar, but there's a couple of details that will help tip you off. First of all, this is my basement membrane, so this is going to be my apical surface. At the top, you have the cells look almost oval. In the middle, to me, transitional epithelium looks like peacock feathers. So here you have, it looks like a peacock feather to me. If you've ever seen the tail of a peacock, there's a bright circle on the end. But they have that, oh gosh, I don't even know what that shape is called. But like the shape of a rounded feather. And then at the bottom, it almost looks like stratified squamous. So transitional, after you see it a few times, it's actually pretty easy to identify because you begin to get that feel for, oh yeah, I get that. There's those ovoid, and then I go into the peacock feathers. So the whole thing with transitional is it's specialized to change shape in response to increased tension. Specialized to change shape in response to increased tension. Well, where does our tension change? In our bladder. So through the day, if you drink a bunch of water, these are going to look very distended, more like peacock feathers and the ovals. If you're a little dehydrated, everything will look small and tight and almost cuboidal. That's what they're showing here is if it's not extended, it looks cuboidal. When it is extended, the shape looks very different. There we go. So it's contracted, it looks like stratified cuboidal. Stretch, it can look like stratified squamous. I go more with the ovoid and the so I would kind of cross that part off. I don't really see the stratified squamous. All right, I'm going to stop sharing my screen. So those were the next three tissues, the next three epithelial tissues. We talked about goblet cells, we talked about microvilli, we talked about why transitional changes the shape, why it looks different at different times, and we'll get some practice identifying those in class. So thanks for watching and have a great day.